This video is about the Aldol reaction. There are different types of Aldol reaction. In this video, we'll be talking about all of the different types of Aldol reactions. So we will be talking about aldol addition reaction, and we'll also talk about the dehydration of the addition product, and retro-aldol addition reaction, and crossed aldol reaction. Okay, so let's get started with the aldol reaction. To begin with, we know that the carbonyl compounds can behave in two different ways. One is it can act as an electrophile, and it can also act as a nucleophile when the alpha hydrogen is removed. Okay, so remember, this is the enolate ion, which is going to act as a nucleophile. Okay, so an aldol addition reaction is where both of these reactivities are observed. Okay, so where one molecule is going to act as a nucleophile, another one is going to act as an electrophile. Okay, so for an aldol reaction or aldol addition reaction, you take two molecules of the aldehyde, or you can also take two molecules of the ketone. Okay, and you react this with a base in the presence of water. Okay, and the product would be a beta hydroxyaldehyde in the case of aldehydes, and it would be a beta hydroxyketone if you're going to start with ketones. That's super easy to keep in mind. Okay, now let's draw the structures for this reaction. Okay, so you're going to take 2 moles of the aldehyde, and again you can do exactly the same thing for ketone. The mechanism is going to be the same as well. Okay, and this reaction is going to be reversible. Okay, and they are going to give beta hydroxy aldehydes. So this is the product. Now, why it is beta hydroxyaldehyde? Again, you have an aldehyde and you have a hydroxy group. Okay, so because the hydroxy group is in the beta position with respect to the aldehyde, so this is the alpha position, this is the beta position. Because the hydroxy group is in the beta position with respect to the aldehyde, it is called as beta hydroxyaldehyde. Okay, now let's look into the mechanism for this reaction. The mechanism is going to be very, very simple. There are only 2 steps involved in this. Okay, first is one of the molecules of the aldehyde is going to react with a base to form the enolate ion. Okay, I'm sure by this time you guys know how to generate the enolate ion. So you have the base that's going to go grab this hydrogen, and it's going to form the enolate ion. Okay, and in the next step, this enolate ion is actually going to behave as a nucleophile. Okay, and attack the second carbonyl compound, which is the second aldehyde here. Okay, so this nucleophile is going to go and attack the carbonyl carbon and thrust these electrons onto oxygen. Okay, so by doing so, it's going to give me this product, this intermediate, And in the next step, remember you're adding water in this reaction. So the oxygen with its negative charge is going to go abstract this hydrogen and gets protonated. And there we have our beta hydroxy aldehyde. So in this one, you can see that this is the first part of the molecule. And here you have the second part of the molecule, or second molecules. Okay. Okay, now if you want to do the aldol addition for ketones, it's going to follow exactly the same thing. Okay, so again with 2 moles of with 2 molecules of ketones, it's going to form beta hydroxy ketone. And when you compare the reactivity of the aldehydes and ketones, we know that the ketones are less susceptible for nucleophilic addition reaction. This we have probably covered in the last chapter. So, and again, for the same reasons, the aldol addition reaction with ketones is going to be slow. Okay, so the order of reactivity is going to be aldehydes are going to be more reactive compared to ketones. So here it's going to be slow. Okay. Okay, so the next reaction that we are going to talk about is the retro-Aldol reaction. And what's the meaning for the word retro? Retro is reverse. So an aldol reaction, an addition reaction, is actually reversible. So the products which you got from the aldol addition reaction, which is beta hydroxyaldehyde or beta hydroxy ketone, when you heat it in the presence of a base, what happens is you will get back the 2 moles of the aldehydes or ketones. So basically it is the reverse reaction. Okay, let's look into the mechanism for this. So here is our beta hydroxy ketone. As you can see, there are no hydrogens on the carbon where the oxygen is attached. So this is a beta hydroxy ketone. This will be cleaved right here to form the 2 ketones. So the first ketone is formed, and the next ketone actually tautomerizes between the 2 structures. And we know that ketone is going to be the most stable tautomer. Okay.